All right, class, today we're going to look at our third method or our third way to solve quadratic equations, and that is by using quadratic formula. Now, we spent a little bit of time here in chapter 12 going back to chapter 5, and the idea in chapter 5 was that we could factor something. We could x factor and we could use zero product property. And again, that's my first line of defense. To me, that's the easiest way to get the job done. But not every quadratic equation is factorable. So let's look at the first equation that's written here on the board. If I look at this first equation, could I factor that equation? Well, when I look at that constant term, there's no way I can take the factors of 6, which are 1 and 6 and 2 and 3, and add them together to get 8, that middle term. That's what we learned. So factoring's not going to work. But did you realize that b is even? Since b is even, I'm going to complete the square, and that's what we learned last lesson. Remember, we've got to get it in the right form, and we would go ahead and complete the square like we learned yesterday. Now, let's look at the second equation. Now, as soon as I look here, I'm going to tell you right off the bat, there's no way I can factor that. It's not factorable. If we'd have come across that one back in chapter 5, we would have said it was prime or not factorable. So, do you think we want to complete the square on that equation? Wow. Well, we'd have to divide everything by 7. Okay, and then we're going to have some nasty fractions in the middle. And so I definitely don't want to complete the square. So the third option, and I use that option when I have really big nasty numbers as my coefficients, is the quadratic formula. Now here's what quadratic formula looks like. First things first, your equation has to be in standard form, which means you need ax squared plus bx plus c equals 0. It has to equal 0. Now, this is quadratic formula, and ladies and gentlemen, you have to memorize that formula. It's the opposite of b plus or minus square root b squared minus 4ac all over 2a. Now, tonight, if you write that out before you do every problem, you should have it memorized by the time you finish homework. So let's see what that means for you and I when we go to do problems. Now, what I've done is I've made a nice little honey-do list for us to go through and do each problem. So step number 1, it has to be in the right form. And when I look at number 1 here, it is in the right form. I have everything equals 0. In step number 2, we're going to identify what a, b, and c are. So when I look here, remember a's what's ever in front of n squared, or my quadratic term, so it's 2. B's what's ever in front of the linear term, that's negative 3. And then c's the constant term on the end, and that's negative 2. So we're just going to declare or state what a, b, and c are. Now we're going to substitute those values in to the quadratic formula. Now let me write the quadratic formula over here again. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. All right, so now let's plug everybody in where they belong. Well, the first thing I need is minus b. So my b is negative 3, and the opposite of that is 3, plus or minus, I need the square root, b squared, well, negative 3 squared minus 4. A is 2, and c is negative 2. So, and then all over 2a. A is 2 again. So basically, I plugged all my values in the quadratic formula where they belong. Now we need to do the math. So where do you think the best place is to start? That's right, we're going to start inside the radical. The radical is kind of like a grouping symbol. And so we're going to do the math in there first. So we've got negative 3 squared, which is 9. Now, pay attention. We've got a negative times a negative, which is a positive. If you're going to make a mistake, you're going to make a mistake right there with the signs. And then we've got 4 times 2 times 2. Well, that's really 4 times 4, which is 16. So let's see what we're left with. 3 plus or minus, we've got x equals. Now, what's 9 plus 16? 25 over 4. So this time, what's inside the radical is a perfect square. So that's going to simplify and give me x equals 3 plus or minus 5, because the square root of 25 is 5 over 4. Now I need my two answers. We've got 3 plus 5, which is 8 over 4, which equals 2. And then we have 3 minus 5, which is negative 2 over 4, which would give me negative 1/2. Okay, so we're going to figure out make sure it's in standard form. It's got to equal 0. Figure out who A, B, and C are and plug them in. And again, sometimes when we do the math, what ends up in my radical is a perfect square. So that's going to take plus or minus the square root, and then we find our two answers. Now, let's look at the next couple problems. If you look at number 2, I actually just wrote the rules up there again for you to see. So is it in the right form? Well, when I look at number 2, it definitely does not equal 0, so we need to make it equal 0. So we're going to say k squared minus 3k minus 1 equals 0. And now I'm going to figure out my letters. I'm going to identify the values for A, B, and C. So A is, well, in front of that k squared is an understood 1. B is going to be negative 3. And C is also negative 1. So now we're going to plug those values in to our quadratic formula. So we need the opposite of B. Well, that's going to be positive 3 plus or minus. We've got the square root of b squared minus 4. A is 1, C is negative 1, all over 2a. So we plugged everyone in. That's right, we're going to start inside the radical. So x equals 3 plus or minus. Now we've got 9. Did you notice once again we got a negative times a negative, which is a positive. So we've got 9 plus 4. Well, 9 plus 4 is 13. Over 2. Now notice what's inside the radical. This time what's inside the radical is not a perfect square. All right, can I simplify that radical? No, I can't simplify the square root of 11. So that right there is your final answer. You could give that to me on the answer sheet. Okay, let's look at number 3. If I look at number 3, is it in the right form? Sure, it equals 0, so we're already in the right form. So let's decide what our values will be. A equals 2. Remember, A is what's in front of the quadratic term. B is negative 6. Remember, B is what's in front of the linear term. And C is negative 8. It's the constant term on the end. All right, let's plug everybody in the quadratic formula. So B is negative 6, so the opposite of B is positive 6, plus or minus B squared, which is negative 6 squared, minus 4A is 2, C is negative 8, all over 2 times 2. Okay, again, I'm going to start in the radical. Nice grouping symbol. So we've got 36. Negative 6 squared is 36. A negative times a negative is a positive. Ooh, looks like we got 8 times 8, which is 64. That works out nice. So we've got x equals 6 plus or minus 36 plus 64 is 100 over 4. So now I've got 6 plus or minus 10 over 4. And now you just got to give me my two answers. So x is going to be 6 plus 10 is 16 over 4, which equals 4. And then 6 minus 10 is going to be negative 4 over 4, which equals negative 1. Okay, let's look at our last equation here, number 4. Now, when I look at number 4, okay, first problem, it is not in correct form. It does not equal 0. Well, I'm going to move this one over. I'm going to move everybody to the left. So and I'm going to put them where they belong. So it should be 4r squared plus 2r minus 5 equals 0. So now I've got it in the correct form. Ax squared plus bx plus c equals 0. A is going to equal 4, B is going to equal 2, and C is going to equal negative 5. All right, let's plug them in where they belong. X equals the opposite of b. Well, if b is positive 2, we're going to say negative 2, plus or minus b squared minus 4ac all over 2a. So if I start in the radical, we've got what? 2 squared is 4 plus negative times a negative is a positive. We've got 20 times 4, which is 80. So now x equals the opposite, negative 2, plus or minus the square root of 84 over 8. Now, 84, when I look at it inside the radical, is not a perfect square, but we can simplify that. We can do 4 times 21. Remember how we simplified radicals back in chapter 11? So x equals negative 2 plus or minus 2 root 21 over 8. Now, do you think we're done? That's right. If you notice, everybody outside of the house has a GCF of 2. So we can reduce that fraction and get, we're going to divide everything by 2, negative 1 plus or minus root 21. If you put a 1 in front of it, I wouldn't be angry, over 4. And that's my final answer. So once again, once we simplify that radical down, we might also have to simplify the fraction. Now, if I look at number 5, fractions. Do we like fractions? Nah. How do we get rid of fractions? Remember, in your best Terminator voice, elimination. So we're going to multiply everything by what we would choose to be the GCF, which is 6. So we've got 6t squared plus, well, that's going to 9t plus 4 equals 0. And now we've got a equals 6, b equals 9, c equals 4. So let's see what happens. X equals the opposite of b, which is negative 9, plus or minus 9 squared minus 4. A is 6, c is 4 over 2 times 6. Negative 9. If I look at what's in the radical, well, we got 9 times 9 is 81. And then it looks like we've got minus. There's only one negative sign this time. What is 24 times 4? Well, 16. And then we got 88. 9. Okay, so we got minus 96. So now I've got plus or minus. Did you realize that's the square root of negative 15 over 12? Hey, as soon as we see that negative number inside the radical, we learned that can't happen back in chapter 11. So the answer here would be no solution.